All right, let's start this session on time. So we're in the home stretch, so you can see the finish line at the end of reInvent. So welcome to SAC315. This session is titled Security Operations, but really what we're trying to convey to you in this session is you have a variety of AWS services that are labeled security or operations. Which ones do you use for what use cases? So my name is Prashant Prahlad. I'm a product manager at AWS. I work on management tools, things like CloudTrail and Config and some of the other tools you'll see. And joining me is Stefan Lenz, who we'll see in a few minutes. And Stefan's a cloud expert at Siemens, and part of what we're trying to show is not just the concept here, but how a customer has actually taken some of these concepts and implemented it. So you have hopefully a good sort of breadth of things to choose from. So I've heard the term DevSecOps. I've also heard the term SecDevOps. So in this session, I'm going to try and understand what that means because I don't really follow. And we'll try to together understand what that means. And you saw this week, we launched a lot of different features and services, and probably too many of them for you to even remember. And we've been launching various services and features at AWS for a while now. So when you have all of these options, we'll try and look at what you can use to meet security use cases. So it's around using these services. And it doesn't matter if you're a large company or a small company. You'll see how Siemens, who most of you have heard of, have taken some of these concepts and implemented them. And hopefully at the end of this session, you'll improve your quality of life. Very low expectations. So one of the reasons we're actually doing this session towards the end of reInvent is because we wanted to actually showcase examples of some of the things that we launched yesterday and earlier this week. So we can actually cover them in a little bit more detail. So what is the problem? Now, I thought I'd demonstrate a problem based on some things I've seen with some customers. There's the software developer, and I'm calling him Toby in this example. So Toby is your really smart software developer. He loves headphones, right? He loves his hoodies, and he loves his free lunch, right? Developers. He also loves being on the cloud. He basically has been working on the cloud through all his professional career of 2 years. It's a lot of time. He loves all of the abilities that come with the cloud, the flexibility, reliability, and all of the goodness. But more importantly, as a developer who's getting started with the cloud, what we've seen works really well is it provides them the freedom to be absolutely creative. They're not constrained by anything. You can do things. It's not about spending time on various other parts of the thing that are perceived to be counterproductive. And you can have that kind of impact that you'd expect a young engineer to have on a large company. And of course, meet Mr. Security. So a lot of us can relate to Joe. We care deeply about some of the security aspects of being on the cloud. And someone like Joe is leading cloud adoption efforts within an organization. There's a central cloud team that actually is caring about security, manages not just AWS, but other infrastructures, deals with security escalations, and oftentimes he doesn't want to be in the critical path because he has so much going on and wants to work hard or smart, but has to work hard. Now, Joe also loves headphones. He also loves hoodies, and he also enjoys his free lunch. He also loves AWS, and he also likes Toby, right? He wants to support these guys and make them productive, but he's ultimately responsible for security. And in many cases, Joe and Toby can be the same individual, and that's really what I think DevSecOps means to most people. But security has a lot going on, right? You have to evangelize cloud. Joe has a lot going on. You have to evangelize cloud within your organization. You have to investigate issues deeply, Oftentimes, security folks are putting out fires, very significant ones, and dealing with compliance regimes and the auditor, who will hopefully audit them about how they're managing their infrastructure. Now, when you have this much going on, you have various sets of AWS tools that can help you. We launched so many of them that you can actually address all of these issues. But don't they all look very similar? In fact, I made one up, right? So there are various tools that can help you, but Joe now has to learn about these services and learn about we're launching features, so we learn about features each of these services are coming up with, in addition to all of the other things he's supposed to do. So it puts us on a path that's not sustainable, right? So you could wonder, it's just more work for Joe who's already stretched. So let's break this down, right? We can actually simplify this, so we can help him. These are some typical tasks that we've seen security professionals perform on a regular basis. The first one, and we'll get into each of them in a lot of detail. The first one is creating policies, right? These are guidelines that you want the rest of the organization to use when they're using infrastructure, be that AWS or anywhere else. Wants to assess if people are following those guidelines. Now, as a professional, he is not scalable, right? So part of his job is not just to be the guy assessing compliance, but also help developers assess their own compliance, right? When needed, he'll have to step in and fix critical issues, deal with escalations, and of course, his favorite part is generating audit reports for his auditor, right? What can be more fun than that? So let's look at each of these things. Creating policies. Now, policies are no longer documents, it's code. I think through your conference this week, hopefully you've seen a lot of these presentations that talk about infrastructure as code and everything is code. So there's no reason security policies needs to be a PDF that you hand out to different people. This can be in code. And there are different ways in which you can actually use this. First one is Trusted Advisor. So Trusted Advisor offers several best practice checks. There's some examples here. But you don't even need to enable them to get started, right? If you have different support tiers, I believe you get different levels of checks, but you don't have to put in effort to get started. So this is an easy way to actually help get your policy in code. Now, if you have many accounts, and if you are an administrator, one way to actually look at Trusted Advisor checks is to get permissions to read the APIs I'm mentioning there, describe Trusted Advisor check summaries and check result. So you can go into different accounts as a security expert and read into the Trusted Advisor checks for that account. Now, the policies or the checks, as they call it in Trusted Advisor, is useful when you have broadly applicable policies like, S3 buckets should not be public writable, for example. And you don't have any exceptions for those. So let me show you this with an example. These examples will get more and more and more complex as we go through the presentation. So if you've used Trusted Advisor before, this should be relatively straightforward. If the video works, which it's not. Okay, so we'll try and do this live. How about that? Can I get a help with the video in the meantime while I'm trying to play this live? So if you look at Trusted Advisor, do not remember my password. All right, Trusted Advisor is under Management Tools, and you have various checks that are running. One of them is security checks. For example, in my account here, I have CloudTrail available in SA East 1, but it's been turned off. So I can actually go ahead and check this on different accounts. Now, if you are managing many accounts, you can actually set up an email that basically gives you a report of Trusted Advisor checks that are happening on a regular basis, right? So that's really what the video was supposed to show. Now, when you go to policies and code, there are various grades. So Trusted Advisor is the simplest one. And then you move to something called configs managed rules. So these kind of rules or checks are useful when you have more specific policies to something as generic as CloudTrail is turned on. So you can actually customize these managed rules to meet your requirements without actually writing any code. Now, and this one's working, believe it or not. In this example, I'm going to actually create a new managed rule. So if you go to AWS Configs console and look at rules, you'll see various sets of managed rules that are available for you, including the 3 that we launched yesterday, and we'll get into that in a little bit of detail. Now, these rules are basically very easy to actually use and get started. So in this case, I'm just going to go to the next one. There are 25 managed rules you can choose from. And the reason why they're a little bit different from the Trusted Advisor ones is you can go ahead and you can actually customize these rules to meet your requirements. So for example, in this case, I'm looking at the IAM password policy. Minimum password length, I'm going to change that from 14 to 12, and my password expiration is 120 days, for example. The defaults are actually for PCI, so you can modify that to meet your requirements. And these rules, as you noticed, I'm customizing them to meet specific requirements. I'm also not writing any code for them, right? In other examples, we can actually see many of these actually meet different requirements. If you have EC2 instances that you think should be of a specific type, now you can actually say, hey, this specific EC2 instance, I'm going to allow only T2 micros in the account. I don't want anyone to launch an M4 or R-type instance. You could specify that, and then the service will automatically check all EC2 instances to make sure that you're only meeting certain requirements. So you see the IAM password policy, you see that in this specific case, I'm not compliant. And if you look at the EC2 instance desired type, you'll see that I have one non-compliant resource. So if you click that, you'll see that I have several instances in my account, and then 2 of them are of type T2 micro, and the one that's non-compliant, you can take a look at what it is and then perhaps fix it or note it as an exception. So we're still sticking with policies in code. You can get more complex. So these are really simple examples to get started. Now, if you have custom config rules, here you can write code to actually check some of these best practices. You don't have to use some of the things we provided. And what we've seen is customers really like the idea of publishing their best practices to GitHub. So there's an open source version of this. So you can take the code, copy it over, and then run it in your accounts. Let's look at an example of that. So it's very similar to the one we just saw. Instead of adding some of the predefined rules, I'm going to add a custom rule. And this custom rule basically is, I've created a policy in my account called DB superuser that has administrative privileges. And I want to make sure that only the administrator has access to this, not anyone else, not any other IAM user in my account. So it's a very privileged policy. I want to make sure that only the right people have access to it. So it's very custom to how I have implemented my specific security policy. This is not something generic, right? Now, For this, you have to write a Lambda function. So if you saw, I basically clicked create a new Lambda function here as I was writing the policy. And when you create a new Lambda function, you have the opportunity to select what we call a blueprint. So this is a template of code that's available to you. And when you select the template of code, you'll see that in this case, I'm going to use Node. You use a language of your choice. I'm going to choose this blueprint, which is a change-triggered blueprint. That means that every time something changes, I have this code triggered, right? And then I wrote some code for this, so this is like a cooking show. Like I'm going to show you the end result. This is the end code, but it's really simple, and we'll walk through it in a little bit. And you know, I wrote this, so I can tell you it is very, very simple. You know, I don't write code for a living, so even I can do it. So here, all I'm checking is there is an IAM policy type, and I'm checking whether the IAM policy is the DB super user policy that had those privileges. I'm looking at the attached IAM user, and I'm making sure that the attached IAM user is of that variable attached IAM user, which you'll see in a second. So only that person is allowed to actually use it. And if you look, I'm doing something more than just checking for compliance. I'm adding the other users attached to this policy. So if it's not compliant, I have more information I can work with if I were, for example, generating a ticket, right? So I'm saying, you know, if there's more than one user, I want a list of all of them so I can file a ticket against them. So I'll choose the role, which you have to do for a Lambda function here, and then, you know, default settings, all the other places. And when you create the function, it gives you an ARN, or an Amazon resource name. Now, let's pop back to how we got here. We're one level down in the stack. So we created the Lambda function. Now we go to the Config Rules custom console and say, this particular Lambda function needs to be triggered when there is a change in an IAM policy. But I'm also going to do one extra thing here. I'm also going to trigger this particular custom rule every hour. So you can not only trigger on changes to the IAM policy, let's say someone changed the policy or attached a user, you could also trigger it every hour. So I want both of these. And the variable we used was attached IAM user, so I'm going to define that variable here. And the person who should be using this is DB super user. Everyone with me so far? We have an intimate audience. If you have questions, yell. So I have this created. It'll take a few minutes for it to run. If you refresh it, I think it ran there. You can see DB super user policy usage rule has completed. It's non-compliant. And then I've created that annotation. Because it's non-compliant, I've said, these are the two users who are non-compliant. So I had user 1, SDS, and user 2 is DB super user. Since we're in computer land, 0 and 1, so it's an array. And I noticed that there are two users attached to it, not one. So I can take an appropriate action, which was detach the user from that policy to make the rule compliant. Now, still sticking with our theme here, this is Joe's first task. All of those policies, you know, that only a specific user should be using a policy, IAM policy, or we should not be turning off CloudTrail. All of these things are available in code. So if you look at AWS's best practices, we have several white papers that talk about best practices. You can actually implement these in code, right? It takes a little bit of investment, but it'll bear fruit, believe me. And as I said, there's a GitHub repository of config rules available. We've actually started with the CIS benchmarks there, and customers are putting in various other things, so you can actually benefit as a group from your peers and use that. So we saw how you can create policies in code. The second task we looked at was assessing compliance, right? Assessing compliance is really around changing from being a spot check when you audit for compliance. Because you're putting these policies in code, you can actually move into continuous compliance. Now, you've been here all week, so you understand that this is a common theme or a common benefit of actually putting policies in code, is that these things can check automatically. When you have continuous assessments, one of the best ways to scale is to make sure that the person, you assign an owner to that assessment. So when there's a result, have an IAM user who's responsible for taking the correction for that. And you can also prioritize assessment using some of the annotations that we just saw. So Config Rules provides a great way to assess compliance and report compliance in a specific configuration. As you saw in the example, you can annotate the results with an appropriate owner, so you can actually use that for ticketing. And for those of you who like to write code, this is in Lambda, so you can pretty much do anything you want, right? You could call the API for your ticketing system and then punch in the result directly into the ticketing system. You could send yourself an email. It gives you immense flexibility. Now, in the context of assessing compliance, I wanted to showcase a new feature we launched very, very quietly yesterday. Now, of course, Werner announced something called the EC2 Systems Manager. Now, this capability allows you to monitor, get instance software configurations, and patch your EC2 instances. Very useful for Windows or Linux instances. Now, what we launched quietly was AWS Config support for these EC2 Systems Manager. So all of that software inventory about things running inside the instance, firewall rules, network configurations, all of these are available in AWS Config. So you can now write rules against them. And of course, we'll try to do a demo of that. Now, if you enable Systems Manager in EC2, you'll automatically start recording configurations in config if you had enabled config to record everything. We're calling this resource type SSM, Managed Instance Inventory. So we'll look at what data we're getting from that instance here. So this is the AWS Config console. So you're seeing a set of changes that happen to those resources, but really the important parts are on the right side here. So think of software inventory as an extension of the EC2 instance. So you see the EC2 instance, this is an extension that includes the software that runs inside the EC2 instance. This is a Windows instance, so you get a list of all of the installed updates on that instance. So a long set of updates, hotfix ID, what time it was installed, who was the person installing it. All of this details is now available inside AWS Config. You get the installed applications. So if you have a Firefox version running, which recently you might have heard there was a vulnerability, you can actually detect which version of Firefox is running in the instance, if it is, and then flag it as compliant or non-compliant. So applications is a pretty big deal. AWS components, so we're not adding any new agents for this particular feature. This is an existing SSM agent or EC2 Systems Manager agent that you already have in your Windows instances. And you can optionally install in Linux instances. So this is not a net new agent we're adding. But you're getting all of these network configurations, AWS components, install applications, and Windows. Now, it's useful, right? More useful if you write rules on it. And we have also launched 3 sets of rules that you can create with this data. The first rule is just checking for a specific platform, right? If it's Windows or Linux, and then what type agent and what version has been installed on it. This is just going to mark some of these instances as compliant and non-compliant. The second one is required applications. So you could say, I want Chrome version 5.1 or whatever else running on this instance, and check for that particular application. And the third one is quite the opposite, which is blacklisted applications. Make sure that nobody's running something that's vulnerable, like Firefox version X on the resource. And just like with other rules we saw, you can actually assess compliance and check whether those resources exist or not. In this case, I'm checking for CFN Bootstrap, which is a AWS application. You can see 3 of the instances have it, don't have it, and 1 of them has it. So those are examples of assessing compliance. And we saw creating policies in code, assessing compliance using things like rules. The next step that you would take as a security professional is actually fixing violations quickly. Right? When you see a violation, you want to be able to react to it. Now, there are several ways to do this again. With AWS, you have many ways of implementing things depending on your preference. CloudWatch events is basically one way that you can actually get an event stream of things happening in your account, like CloudTrail APIs being called, and you can trigger a specific Lambda function to fix things, right? Or, like you saw in custom config rules, instead of putting the annotation in the account or creating tickets, you could actually go ahead and fix it if your Lambda function has permissions to do so. So you have to provide the right set of permissions to your Lambda code to actually fix it. And we'll see an example of that with CloudTrail data events. Now, CloudTrail data events was another one of those quiet features we launched before Thanksgiving, leading up to reInvent. And this specific feature allows you to capture API activity on S3 objects, right? So even like read activity, like someone does a get object within a bucket, you could get an API call for that. And of course, the usefulness of this is being able to react to bad actions, right? So let's take a look at that. Enabling this feature is very simple. You go to CloudTrail. You have a set of trails in your account. If you don't have one, you have no excuses. As you're coming to a security talk, you have to turn on CloudTrail. It's not debatable. In this case, I have CloudTrail running, and keep in mind the S3 data events feature is an opt-in feature. So you have to specify the bucket you want CloudTrail to record object level activity for. So in this case, I have a bucket in my account called random bucket name, and I think this one is important. So I will start recording all of the object level activity for this specific bucket. Now, I'm going to also write a Lambda function here, very simple one, that will basically react to an action within that S3 object, right? So in this example, I'm going to actually put an ACL or an ACL on the object. So I'm going to mark that object as private, right? To make sure that any object that's put into that random bucket is marked private. So no one can accidentally, for example, mark the bucket object as public. The code here is actually relatively simple. Copy-pasted from another window, but I wrote it in the session earlier, actually yesterday. And you can see it's not good code because I have print statements all over. I wrote it, and it's kind of poor man's debugging. So all I'm doing is getting the bucket name, object name for that resource, and then basically getting the ACLs on that, and then doing a put object ACL and marking that ACL as the private ACL. Providing the right set of permissions to the Lambda function. I create the Lambda function. So now we've set up CloudTrail. We've created the Lambda function, and let's try to bring those two together, right? And the thing that brings them together is CloudWatch events. So if you set up CloudTrail and you got the object level activity, that will be available in CloudWatch events. And here I'm going to go to CloudWatch events, specify object operations. So anytime someone does a put object or a put object ACL, I will trigger the Lambda function we just wrote, which is going to remediate it. And of course, it has to be on that specific bucket that we care about, right? So the function is available here, mark S3 object as private. There's a minor detail here. I have to extract the CloudTrail API from the CloudWatch event, so that's why I'm just looking at the object detail. But you could handle it in the Lambda function as well. Give this a meaningful name, like mark S3 objects as private, and a useful description that basically helps you understand that what this function is doing. So if CloudTrail is set up, it's generating all these API events. I have a Lambda function that's the result, and the CloudWatch events piece is going to connect the two. And now I'm going to go to S3 and perform an action like a developer would. Go to the bucket name for which I'm recording data, and I'm going to upload an object. Now, when you upload the object, something important like billing data, billing bill of materials, kind of important. Set the right permissions on it, of course, by marking it public, which is probably not the right thing to do, right? You start the upload, and you'll notice that as I've uploaded this, and you look at the permissions on the object, you'll notice that it doesn't have any public readable permissions. because what happened in the background is the CloudWatch event was triggered, CloudTrail recorded the API, the CloudWatch event was triggered, the Lambda function fixed it, all in just a few seconds. But I'm going to do it again. I'm going to put object ACL, mark it as public, give everyone edit permissions, the whole world basically. And this is not, you can actually hit refresh, and within that refresh cycle in the console, you can actually see that the permissions have changed back to remove those bad permissions I put on that resource. So you can react to things very, very quickly. The service that actually is supporting this in the background with CloudTrail and CloudWatch events is ridiculously fast. I'm not going to give you an SLA, but it's ridiculously fast. So these are examples of how you can fix things. Now, for fixing things, you have sort of a broad set of options, right? You have right from Trusted Advisor that's creating awareness. You have config managed rules that are also creating awareness for specific resources, custom rules with remediation, and we saw examples of using CloudWatch events with Lambda. So you have, depending on how sophisticated you want to set up your infrastructure, you have the simplest option to the most, not complex, but most sort of building blocks type of option. Fix violations was something we just saw. Let's see how you can deal with escalations. Now, escalations happen by definition when you least expect them, right? But you can be prepared for them. And when you deal with escalations, it's very important to have factual information, and that you can get through monitoring systems, right? So, for example, if someone tries to turn CloudTrail off, you can increase surveillance on that resource. You can increase, for example, VPC flow logs. A timely response to an escalation is to quarantine the resource. And there's a demo we did earlier today, for the code for which it's Dev 302, and I didn't want to repeat the demo in this session for people who attended both. But we have an SOP in code for that, and I can provide a link to that GitHub repository that contains the code to actually start monitoring these resources when like enabling VPC flow logs when something suspicious happens, and being able to actually react to it. So dealing with escalation is really simple if you turn on logging. It's as simple as that. It could be VPC flow logs, it could be CloudTrail, it could be various other CloudWatch logs that you can enable for your applications. The timely response, in order for you to have a timely response, you have to have data to support it, and that's enabled through some of these services I mentioned. Now, generating evidence. This one's interesting. This is possibly, we have various sets of tools that help you generate audit-ready reports. You just saw an example on my live console where I looked at security violations being emailed to Joe every week. CloudTrail is archived in S3. You basically don't get the option of not delivering it to S3. You can actually create lifecycle policies to make sure that data exists. I cannot think of a good reason to delete CloudTrail API data. This is super useful and available to auditors. CloudTrail allows you to also use the console to look up API activity for 1 week. And of course, you can also send your logs to CloudWatch events, CloudWatch logs, so you can use them for longer-term lookup. AWS Config has a feature called Snapshot that captures the state of all your resources at a point in time. It gives you a breadth view of resources. And I'll mention another API, and of course, maybe auditors will use CLI someday, but it's possible to actually use this single CLI command to get the history of any resource. So you just say, I want to look at this EC2 instance between time 1 and time 2. And you get a full history of all the changes that happen to that resource as captured by config. And that one API applies to all the different resources you exist. Yeah, someone like Joe with these kind of reporting and being able to collect evidence would say, I can automate this stuff and make it available across, this is all of the features I described, all of the resources and services we just saw are available in CloudFormation, so you can templatize them, right? And these templates are also available in GitHub. So someone like Joe would say, I'm ready. Audit me right now, right? But again, this is fictitious character. So let's invite Stefan on stage to see how the real world works. Thanks, Stefan.
Yeah. Thank you, Prashant. I would say some words about our company. I'm from Siemens. We're a global company and have about 170-year history and doing industry, and now on the way to the digitalization of what we are doing. I'm from the digital service, from the customer service, from mobility, and we are building trains, we are building the environment for train operating, and therefore our highest good is 100% availability for our customers. We have tons of data which we are getting from our trains and from the environment, and we want to turn this data into information and into availability for the customer. Therefore, we have a data policy that all the data is owned by the customer, and we have the right to use it, and we have the right to work with it, and that helps us to gain all the information which is in the data. We have therefore the Religent platform, where we have like common, I think you have also something in place, data transmission, data processing, data evaluation, and data visualization, which we are using for working with the data. And all this is now based on the AWS platform and helps us to do it in an agile and flexible way. Here's a short overview on what we are doing on AWS. We have the S3 input buckets, we have the SNS, SQS, Beanstalk, and all this is the technical stuff we are doing to do processing the data. But the important things Prashant mentioned before is the government tools on the right side. We have on Siemens a strict government policy and a compliance policy for all IT stuff we are doing, and therefore we have a 4-layer account setup for our projects defined, where we have a sandbox where developers can play with all the AWS stuff. Then we have a dev account where we can develop in a more organized way. We have then the testing account where all developed applications will be deployed to in an automatic way, and then the production account where the production code runs and no developer has access to. On the dev and test account, we try to give our developers a mostly free experience on how they can use AWS tools. And to give the developer this freedom, we use additional tools like Amazon CloudWatch, like CloudTrail, AWS Config and Rules, and the Trusted Advisor to gain the needed information for the compliance and governance rules. We for that, I have to mention, in addition, that we start all accounts we are deploying with a preset of activated functions, like we have an automated activated CloudTrail on all accounts, which we are using the vault principle that all the data from CloudTrail is going to another account operated by our ISAC department and the information security department, where we, as the operator and the developer, as the user of the platform, of the tools, do not have an access to, so we have a guaranteed auditable place where all the data is going to. And then we have here the topics to service mapping. Our main security demands are coming from the ISO 27001 270.0.0.1 and the IEC 62443. And here are the main topics of the standards, and I've put the chapters also where they're referring and mapping on which tools we are using for doing the stuff. Like Prashant showed before, we are trying to automate most of the things, and we are using like access controls. We have the requirements to do password complexity checks, password oldness, and so on. And we're doing this with AWS CloudTrail on the one side, and the Trusted Advisor activated by default and reporting to the owner of the accounts that he has an easy and understandable way on how he could have a look on what's going on his accounts, and he could have the overview of all it. Then there's asset management and the communication security stuff, also the compliance, where we use all the tools to do the automation things and to do the governance on the account. Then there's cryptography. I have an example in the next slide. We see how we're using Cloud Config Rules also for that, and information security aspects of business continuity, was mainly about having a IT disaster recovery plan in place, information security incident management, like Prashant told you before, is like the escalation procedures and how to escalate incident on the platform, and the operation security, where we gaining all the information together to have a good overview. Then there are the AWS Config Rules. We are starting with predefined rules, encrypted volumes. It's important for us that all volumes in S3 is encrypted, also the EBS buckets and the EBS volumes. Then that CloudTrail is always enabled on all accounts and on all regions per default. Then the root account MFA has to be enabled. The IAM password policy has to be fulfilled for all the accounts. Then that also the RDS storage is encrypted. And for us, it's very important to have the required tags in place. So we have tags like cost center, owner, and organization unit to quickly that we can quickly identify to which project and to which owner, to which developer the project and the systems belongs. And then we have some custom rules. We started with, like Prashant showed before, the GitHub repository, AWS Labs config rules, and there is some special rule we have in place that is RDS in private subnet, because of it's very important for us that all the RDS instances our developer can launch are always in a private subnet and protected. Also, advanced IAM policies are in place, and advanced security group requirements, like there's no unencrypted ports opened to any service we are launching in the AWS. As I told before, we have a default set, which we globally starting on all accounts on AWS. So our IT department, if it hands over a new account, it's always activated the CloudWatch and the CloudTrail. Then we add an Amazon SNS, therefore that we get the notifications from that. That's the audit log files, and the config changes we're doing via AWS Config, AWS Config Rules, where I showed you before. We have the special rules for monitoring and looking on what's happening on the account. Then we have the Siemens governance requirement, which are very important. We have the 4 eyes principle for all the activities on the systems, where we use the trusted advisor, also for the IT security guys and for the operators who can have a look easily on the trusted advisor what's going on and have an overview on the important things going on. We have the regular checks also by the trusted advisor and in advance by the config rules done on the platform, and that helps us to operate all our accounts in a safe and secure way. We recently activated flow logs, and now the next steps are to have a look on what's going on in the network, to establish monitoring on what's possible. And I have recently seen a cool talk yesterday, I think, how to automate it with artificial intelligence to monitor the flow logs. Yeah. The conclusion. Make security initial part of the developments. As Prescient told before, it's officially called DevSecOps, but my opinion is that SecDevOps is the better name for it, because it's security first. Werner Vogels told it yesterday on the keynote, and also Stephen Smith from Amazon has a security should be step zero concept propagated, and I think that is the most important thing for us, that everything we are doing with the security aspect in mind. Then get a clear view what the requirements are. We have a full list on requirements from our ISAC department, and I think the biggest change in mind was that we didn't have to fulfill it because of they are there. We have to fulfill it because of they are important. And that is the mind change. I think it's very important also for our operations, that IT security is not an enemy. It's a sparring partner where I can mess with, I can discuss with. And that's very helpful for the future task, that we have a good IT security department where we can spare with. And you heard it in the last sessions, I think, enough, but automation is the key to success. Do everything automated. Try to keep out human beings from important things like the production environment. You can do it on development, on the sandbox accounts, but on the production environment, there has to be everything automated, and that, I think, is our key to the success. So, I have to say thank you, and remember to complete your evaluations, and have a good home flight this afternoon.
Thanks, Stefan.